In this lesson, we learn about this thing called scientific notation, which is a way to write very large and very small numbers. So if you think of scientists who work with planets and things in outer space, they're dealing with things that are millions of trillions of miles apart, and they don't even use miles because that's such a tiny label for them. But they use very large numbers. A scientist who deals with things in the microscope or atoms, they deal with things that are very, very tiny. And so they use scientific notation because they need a way to write these very tiny numbers or these very large numbers because commas and zeros doesn't work for them. So the rule for scientific notation, and you'll write this down in the box with me, is you make a number from 1 to 10. So we're looking at, it could be an integer or it could be a decimal, but the smallest you can take is 1 and the largest you can take is 10. Then you're going to multiply by 10 to the certain power. And this power that you're going to multiply by tells you the number of places the decimal moved. So if you have a negative exponent, that means you're going to move the decimal to the left. Because if you think about a number line, negative numbers are on the left-hand side. And if you have a positive exponent, you're going to move the decimal to the right. Now, the movement is always based off of scientific form. So you'll see what that means in a second. So let's decide what our exponents should be. So here we have a number, it's between 1 and 10, 1.9, and we're multiplying by 10 to a certain exponent. Now the exponent is missing because that's what we have to do. So here's where they put the decimal between the 1 and the 9, and where did it go? It moved all the way over here. How many places did the decimal move? It moved 4 to the right, so the exponent is 4 because it's positive and I went to the right. Let's look at number 2. They put the decimal right here between the 3 and the 4 because that's where it belongs to make a number between 1 and 10. So if the decimal point is here, it moved 3 to the right, so that's an exponent of 3. Now let's look at going the other way. I have the decimal point here between the 4 and the 7 because that's where it would be to make a number between 1 and 10. And now the decimal moved 3 to the left, so that's a negative 3 exponent. The exponent tells you the number of places the decimal moved. Here it would be between the 2 and the 3. So if I put the decimal here, it moved 2 to the left. That's a negative 2 exponent. Pause the video and see if you can try the other ones on your own. Now here's one helpful tip you can use if you're looking at a negative exponent. Chances are it's a decimal value. If you're looking at a positive exponent, it's going to be a larger value. So let's practice writing in scientific notation. So the first thing you have to do is write a number between 1 and 10. So where could you put the decimal point to make a number between 1 and 10? There's only one place, and that's between the 7 and the 3. So it's going to start out as 7.3 times 10, and now I just have to figure out the exponent. So the exponent tells me how many places the decimal moved, and I'm moving it 6 to the right, so that's an exponent of 6. Now, a lot of students make the mistake of thinking that the exponent tells you how many zeros there are. That is not the case because there are 5 zeros, but the correct exponent is 6. It's the number of places the decimal moved. Where would you put the decimal point in number 10? There's only one spot, and that's between the 6 and the 3. So that would be 6.3 times 10. And now I have to figure out what the exponent is. Well, in order to move, it's going to move 10 spots, so the exponent is 10. If you want to pause the video and try 11 through 14 on your own, go for it. So let's put our decimal point between the 2 and the 4, because that's the only spot. There will only be one spot So look for it. So I get 2.42 times 10, and the exponent here, it moves to the right, is 6. This decimal goes between the 5 and the 2. So I have 5.26 times 10. The exponent is moving to the left 6 spaces, so that's negative 6. Here, it's between the 8 and the 2. And it's moving to the left 11. And here it's after the 4. So it's 4 times 10. And the exponent is negative 6. Hopefully you got all those right and you tried them on your own. Whoops. Can't make my 6 right. Okay. Now we have to go backwards and write them in standard form. Standard form is when you use all the zeros and the commas, which is what the scientists don't like when they have to write their very small and large numbers. So I'm going to move this decimal point right here 3 spaces to the right. So scoop them with me, 1, 2, 3. So one of the spaces gets taken up by the 5, but there are 2 other spaces and you fill those with zeros. So this number is 3,500. Remember, it's not the number of zeros, it's the number of places the decimal moved. This decimal moves 6 to the right. 1, 2, 3, 4, 5, 6. So 2, 4, 8. And there's 4 empty spaces left. And so this is 2,480,000. Number 17 moves 4 to the left. 1, 2, 3, 4. And there are 3 empty spaces. No commas here because you don't put commas in decimal values. 0.00051. And number 18 moves 7 to the left. So there's going to be 6 empty spaces. 4, 6, 5. Remember, the one rule about scientific notation is that the number has to be between 1 and 10. So is number 19 written in scientific notation? The answer is yes, because 5.9 is between 1 and 10. What about number 20? Number 20 is as well, because 8.3 is between 1 and 10. Is 21 in scientific notation? It looks very close to scientific notation, but it's not. 0.9 is not between 1 and 10, so this is no. 0.9 is less than 1. And you have to be greater than 1, less than 10. Read the example and then see if you can try it on your own. If not, read the example and then play and I'll do it with you. So they give us this little hint that says you can compare the densities by writing each in standard form. So the water in standard form, well, this scoops over 3 to the right. You get 1, 0, 0, 0. So that's 1,000. The brick scoops 3 to the right. That's 1,840, 1,840. And this scoops 2 to the right, which is 641. So it tells you that if you're heavier than the water, if you're denser than the water, then you sink. If you're lighter, then you float. So they say to explain what happens. So we'll say the brick sinks and the apple floats. Example 2, a dog has 100 female fleas. How much blood do the fleas consume per day? So fleas are very tiny, so clearly they're not sucking up a pint of blood a day. We want to know what 100 fleas consume. So one flea, according to the picture, consumes, oh, I'm going to write it in standard form, so I'm going to scoop it over 4 times. I'm sorry, 5 times. And I'm going to multiply that by 100 female fleas. So that gives me 0.0014 liters. So I'm not going to, like pass out from lack of blood after 100 fleas have, well, hopefully I don't have fleas. Anyway, okay, so that's certainly not a lot of blood. An album receives an award when it sells 10 million copies. An album sold 8,780,000 copies. How many more copies does it need? So I can easily subtract that. That's 10 million minus 8,780,000. And I get 1,220,000. But none of those are choices because they want me to write it in scientific notation. So in scientific notation, I put the decimal right here at 1.22. And from scientific notation form, I have to move it 1, 2, 3, 4, 5, 6 spaces to the right. And so that is why it's letter C. Last one together. The table shows when the last 3 geologic eras began. Order the eras from earliest to most recent. So if you want to try this on your own, go for it. If not, do it with me. If you're not comfortable doing this on your own, then let's write them out in regular and standard form. So I'm going to move this over 8 spots. And this is the number. I'm going to move this over 7 spots. And I'm going to move this over 8 spots. All right, now I need to think about in order that they are from earliest to most recent. Well, the earliest is the one that's the largest number of years ago. So the largest number of years ago, if I've done my commas correctly, is the Paleozoic. Then the next one would be the Mesozoic. And then the most recent is the Cenozoic. And you could have done that by looking at the scientific notation if you're comfortable with that. You see that this has the largest number and the largest exponent, so it's going to be the furthest away. And this has the smallest exponent out of all 3 of them, so it should be the smallest one. If you have any questions, write them down, ask me when you come to class, and we will do lots of practice with this when I see you then.